Hello everyone, my name is Sayarsha and my roll number is 502 and I am from CSC third year and my topic is what is automata and theory of computation. So what is meant by computation? So here is the definition. It can be defined as finding the solution to a problem from the given inputs by using an algorithm. So we are going to find the solution which is meant by is nothing by outputs from the given inputs. So we are going to give some inputs for it- for the model, and the model is also consisting of an algorithm. So it is using that algorithm, uh, and it is applying the algorithm on the inputs so that we are going to get an output. So what is meant by theory of computation? So it is a branch of computer science that deals with how efficient can a problem be solved by using an algorithm. So the field is divided into three areas. First one is automata theory. It is the study of abstract computational devices. And second one is computability theory. It deals with how extend a problem is solvable on a computer. And last one is complexity theory. It deals with how efficient the problem can be solved. So there are three major aspects. First one is time complexity. How many steps are required to perform I mean, how many steps to required to perform an computation? Means how many steps are required. Sorry, the slide is this is the slide, and now we are moving to second slide. So next one is space complexity. How much memory is required to perform the computation? So model of computation. It allows it is a definition of set of allowed operations used in the computation and their respective costs. Model of computation is a model which describes how an output of mathematical function is computed given an input. Next one, model of computation can be classified into series models, which is nothing but finite state machine, push down automata. Third one is Turing machine, and parallel models, multiprocessor model, work depth model, parallel random access machine. So fundamental concepts of automata theory. So let us learn about fundamental theory. Fundamentals of automata theory. First one is alphabets. So what is an alphabet? An alphabet is a set of symbols. So we give it a symbol, which is this one. So this is the symbol of alphabets, and next one is so next one is strings. What is a string? A string is an abstract entity which indicates a letter or a digit. So a string is defined as finite sequence of symbols. So nothing but how we write in programming languages like 101 and or ABC like that. Example is 01 are symbols and the string would be 0110. So if we take another example, ABC are the symbols or characters. So the strings would be AABB, and ABB, So these would be the strings and length of the string. So length of the string would be indicated as in modulus of W. W is nothing but the string. So if you take 0110, so what is the length? It would be 4. So it is a 4. It is a length. Its length is 4. So empty string. What is empty string? So string without any characters or symbols. So we would define it with epsilon, which is nothing but this Greek letter. This is nothing but the epsilon. And coming to the next topic, operations on strings. So what are the operations that can be done on the strings? So first one is concatenation, nothing but an addition. Concatenation of two strings is writing of first string followed by second string. So if we take 0 0 as a S1, which is the first string, and 1 0, it's the S2 and second string. If we concatenate them both, it would be of 0 0 1 0. And i- and we have to note that S1 S2 is not equal to S2 S1 in this case, and it shouldn't be also. And I mean, it can be. And next one is alphabets. An alphabet is a finite set of symbols denoted with we use notation epsilon power r, sorry, sigma power sigma. So we denote alphabets with sigma. And next one is languages. It is a set of strings. I mean, it's a set of strings, all of which are chosen from alphabets is called language. It is denoted by L, and the language is defined as non-empty string of alphabet character is word. So coming to the next page. So what is finite automata? So mathematical models are central theme of computer science. The finite automata is a mathematical notation of system which directs input and output. If a finite number of internal states and the system can be in any one of the state, if its output depends only on input, then it's called automata. Depends on input and states, then it is called automata with memory. So if it here what it say means what it did say. So the output is only dependent on the states. So it is nothing but automata. The output depends on both input and the states. So it is automata with memory. So what is FSM? Nothing but finite state machine. A finite state machine is a mathematical model of machine which can only reach a finite number of states and transitions. Finite finite state machine is also called FSM, or it is also known as FA, finite automata. FSM is a model of computation consisting of sets of states, a set of inputs, and a rule of map which state to another states. Means here is a FSM for the traffic lights. So here we can see that red from red it is moving to yellow, yellow it is going to green, and from green it is going to red. So there are some states and there are some transitions. So it can be a finite state machine. A traffic light starts off by showing red and then makes a transition to green light and finally displays yellow light. Sorry, sentence is wrong. It starts with red light and goes to yellow light, and at last it moves to the green light, and after then it moves to red light. FSM is a good design for the programs such as text editors and lexical analyzer. So what is meant by deterministic finite automata, DFA? DFA is an electrically determines. So M is equal to Q summation and delta Q naught and F. So here Q represents finite number of states, sigma represents finite number of inputs, and delta, which is nothing but transition function. Q naught is the initial state and F is equal to final state. So this is my seminar, and thank you.